Good evening, class. Today I'm going to be talking about teaching crosswind takeoffs in a Diamond DA40. This is for fundamentals of instruction. My name is Robert Hofer. We'll jump into it. Lesson objectives are going to be to teach proper technique for crosswind takeoffs. I want to go over some basic aerodynamic principles related to crosswind takeoffs, apply instructional methods from the instructor handbook, and safely execute the tasks in the airplane. Here are the references that I used for today's lesson. Material for our students is going to be an E6B or an E6B calculator, the DA40 Pilot Operator Handbook, and the Private Pilot ACS. Goals for today's class is going to be to understand what a crosswind takeoff is, how to calculate the crosswind components using your E6B, and aerodynamics during crosswind takeoffs, and flight control manipulation during taxi takeoff and in flight. Aerodynamic factors to consider is that crosswind components typically cause side drift on the takeoff roll. In order to counter that, we place the aileron into the wind. This helps counter that lift and center everything up. We utilize the rudder, which will counter the weather vaning and keep the aircraft on center line. And we want to make sure that we have a smooth transition as our airspeed increases and that crosswind component is less of a factor. The Diamond DA40 has a max demonstrated crosswind of 20 knots. We rotate at 59 knots. VX is 66. VY in climb out, which we'll plan to climb out at, is 72 knots. It does have longer wings than a lot of other private pilot aircraft, so we need to take that into account, make sure we have careful aileron control throughout the execution of the maneuver. During taxi, we'll want to have full aileron into the wind. We can either utilize the information off the G1000 or from the weather sock or any other items within the airfield that can indicate wind speed and direction. So if the wind is off the right side of the aircraft, we will be placing that aileron to the right, fully into the wind. We have a tailwind, we'll place the aileron forward and dive away from it. And with a headwind, we'll have the aileron back slightly. On the takeoff roll, we're going to mostly maintain correction with the rudder to maintain our heading. We will keep that aileron into the wind as it mentions there on rotation, and then we'll establish a crab into the wind on the initial out. In order to calculate our crosswind component, we're going to utilize the E6B. Proper technique for this is we'll place the E6B on the table. We're going to rotate the wheel so that the wind direction is under the true index. From the center, we'll make a mark outward along the radial at the distance equal to the wind speed. Rotate that wheel so that the runway heading is now under the true index. And then we'll read our mark relative to that position. Horizontally, that's our crosswind component, and vertically is our headwind and tailwind component. A couple of rule of thumbs we can utilize for this. If the wind direction is 30 degrees off our heading, the crosswind is half of our wind component. 45 degrees off heading is 70, the crosswind component 70% of the wind component. And if the wind is 90 degrees off, that wind component is our crosswind. So in this situation, I would give our student an example. We typically take off runway 12 or 30 at the airport I fly out of. So my example would be taking off runway 12 with winds 150 at 30. I would have the student utilize the E6B and then confirm this with the rule of thumb that we mentioned before. Common student errors I see students exhibit during this maneuver is insufficient aileron input, over controlling the rudder, improper crab transition, and drifting after liftoff. On that point, as far as drifting during takeoff, with utilizing the G1000, we can have that directional bug that'll indicate our travel and kind of let us know if we're drifting one way or the other. As far as safety and risk management goes, I'll talk through some abort criteria if directional control is lost on the takeoff roll. We want to make sure we avoid over rotation. I like to utilize a technique where we rotate slightly above our standard rotate speed during crosswind and tailwind takeoffs, just to give us a little extra buffer. And then we'll continue to monitor the runway condition and wing clearance. Completion standards, looking for the student to maintain centerline plus or minus 5 feet. Ensure that they have proper aileron and rudder coordination throughout both the takeoff roll and after takeoff. So we have a smooth transition to climb, and that the student's able to accurately explain the aerodynamics that are happening. Biblical interpretation, Proverbs 4:26, ponder the path of thy feet, let all the ways be established. So application, we want to stay centerline despite the winds of distraction. There's a lot that happens during this sort of maneuver, and we want to make sure that we're confident when we're doing our crosswind takeoffs. Here are the references I utilized for today's lesson.